we move very quickly. Yes, please, 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 please. Anybody. Just maybe the solubility, so that as you continue, because we are still on metal, on the salts. So while we'll be reacting with some metals, we'll be finding that the ions of some are dissolving, others will not be dissolving. So for example, nitrates, solubility of nitrates, we can even talk about that before even we go to now the preparation, because you're in the preparation. So somebody can say anything. Because I think we are 4 or 5. Everybody will have theirs. For example, I can give Muaura for nitrates to say something about nitrates. Mine, you can say something about sulfates, maybe Stella, just like that, and then we continue.
Okay, good evening. Good evening.
Okay, good evening. You can continue, Muaura. We can hear you very well.
Oh, okay. About the solubility, I think I noted something. You told us that all nitrates are soluble.
Yes, that's true. All nitrates are soluble. Now, Tumaini, you can say something about carbonates. I'm just following the way it is being shown. If you cannot converse, there's no problem. You just do. So, Stella, I think you're saying all sulfates are soluble except lead and zinc. Okay, Stella. So sulfates, zinc is okay. I don't know if you confused something, but lead sulfate actually is insoluble, but it is not zinc. There is another name. There is something else. Barium. Barium is insoluble. So we're just reminding ourselves. So it is barium actually. So all sulfates are soluble except lead, which is correct. So lead is okay. Zinc actually is soluble. It's one of the soluble. So it should be barium. Yeah, barium. Yeah, which is okay. Of course, barium now we have two salts. We have the sulfate and the sulfide, which we'll talk about that only being sulfinates compounds. So it is normally used to test for barium, is normally used to test for presence of sulfate and sulfide. So sulfide is the one with SO3, sulfate is SO4. So we'll talk about that one later on. Who else is in? I don't know. I thought we were 6. So somebody else can give me marine carbonates. We can give something on carbonates. Because now when we be preparing, we'll be seeing those things coming out very well, especially the solubility. That is why I wanted us to remind ourselves. So somebody else can talk. You can just do so at least now we have understood. Yes.
All carbonates are insoluble except sodium, potassium, and ammonium.
Yeah, so the 3 are very special. I think even we had noted somewhere that all the salts of sodium, potassium, and ammonium are soluble all through. It cuts across all of them. Chlorides, sulfides, sulfates, all of them. It cuts across. They are very soluble. What is remaining? I don't know. Chlorides. I think chlorides is a special case. This is a special case because we have a condition for one of them. So maybe somebody can say that one, and then now we move on to preparation itself.
Okay, anybody? All chlorides are soluble.
Soluble, except silver chloride and lead chloride.
Except lead chloride and silver chloride, but lead chloride is soluble in hot water.
Yeah. So actually, lead, once you warm the water, I was trying to change my internet, but it is okay. Once you warm the water, if you had 2 chlorides inside, which one was silver and one was lead, which is okay. James, you're okay. The lead chloride or the lead chloride, depending on how you were taught previously, will dissolve, but the silver now will remain. Of course, now it is very, very important for us as we're going to do this one, as we continue doing this now preparation, the next subtopic of preparation. It is very, very important for us to remember the actual equations, a writing of equations, the chemical formulas, the chemical names, and the chemical symbols of each of the metals that we'll be talking about. Ions, both ions. I'm talking about both ions, the cations and the anions. So it is very important. Now let us start this one. I hope everybody can see the screen. If you can't, you can say something. If you cannot see the screen, if you cannot hear me very well also, please say something. Or you can just put it on the chat. Yeah. So before we continue, let me check if somebody has. So there's no concern. So we continue. If you have a question and you see that you can't raise up your hand or you can't say it by unmuting yourself and talking, please post it on the wall. We will be checking the. Of course, if you also have questions, you still post them on the wall. So anyway, you can continue now. So in preparation of salts, we have two types of salts. We have the insoluble salts and the soluble salts. Insoluble and soluble. Soluble salts, the reason why I wanted us to remind ourselves is because we are going to prepare the soluble salts. So you know the examples of the soluble salts. So in this case, in the preparation of the soluble salts, most of the time, you will not find me talking now of, for example, zinc carbonate or something that is not soluble, because we know that we are preparing only soluble. So anything up here, I will not talk about lead chloride because it is insoluble. So it is very important for us to differentiate or to know the differences. Now, so we go. Soluble salts can be prepared by using the following methods. So those are the methods that can be prepared: action of dilute, acids or metal carbonate or hydrogen carbonate. That's number one. I think I discussed this on the other day, but we can just remind ourselves before even I go to the actual notes. So action of dilute, acids on metal carbonates. I said the other time, when you react an acid with a carbonate or an hydrogen carbonate in a form three things. It normally forms a salt, of course, because it is an acid and something that has a little bit of bases inside. It will form also water. So it forms salts and water, and because now the carbonate, it has to be taken care of. The CO, so it will produce CO2, which is more stable than CO. Now, action of dilute acids on metals. This one actually, B now. I'm at B, yeah? I'm just discussing, but we'll still discuss the Mukochin, yeah? There's a place that I'll explain more. This one, I'm in B. Action of dilute acids on metals. Now, this one was a method that we used in Form 1. If you can remember very well, in Form 1, there is a topic called, is it water and hydrogen? Hydrogen and water, that topic. Hydrogen and water, one of the method of preparing hydrogen in the lab is this one. So this one, when you react a metal, and of course we normally take care of the metals. We have metals that are very reactive with water. You remember, sodium, of course, most of the group 1 sodium, potassium. Now, if the reaction is very explosive when it is with water, what about we introduce an acid? So we don't use those metals because it is very dangerous. Now, there's something else we'll talk about when I'll be talking about this one. We'll be talking about the hierarchy, which is the reactivity series of metals. Tumaini? Yeah.
Yes.
Yeah, you can mute yourself and let's have a question. You have a question?
No, I do not.
Yeah, you had admitted yourself and there's a lot of sizzling sound. Huh? Okay, thank you very much. So I was saying, in action of dilute acids on metals, there are metals that are not supposed to be used in this reaction, and there's a reason for that. And I gave an example of, for example, when you react, we're just doing revision anyway, because I know that topic will be done later on. When you react water, for example, with potassium, that reaction is explosive. Yeah. So I was saying, you can imagine now if it is reacting with water explosively, and water is neutral. What about if we introduce something else that has an acidic nature? That one will be now starting fire or being destructive. It is like making a bomb, which now, so I'm saying some of the metals will not be used. Another reason why some of the metals might not be used here, or this method might not be used to prepare some of the salts, is because hydrogen could be more reactive than that metal. So in the reactivity series, I was talking about the reactivity series of metals. You should remind yourself about the reactivity series of metals, where we have potassium at the far end, who are the most reactive. Huko chini we have kina gold. Yeah, we'll find gold there. So those ones now are very dangerous. Gold and mercury, huko chini. Those ones might not actually displace hydrogen because it is no, because it is more, hydrogen is more reactive, so it will not displace it from the acid, because we said acid actually is hydrogen something, hydrogen chloride for hydrochloride, hydrogen nitrate for nitric. Yeah, and then we continue. Action of dilute acid on an insoluble base. So we hapo juu pia we mentioned some insoluble bases, kina calcium oxide, those ones. I think we mentioned those ones. The amphoteric oxides also will be affected here because it reacts with both bases and acids. Amphoteric oxides are oxides that have a characteristic of acidity and a characteristic of basic nature based on the environment. I think that one will be, it will be mentioned a lot. Justin?
Sorry.
Okay. Make sure that when you're coming in, or if by mistake, imejifinya, it is understandable. I think that one is okay. Now, number D, which is here, action of dilute acid on a soluble base. Those things, they are the same. The only thing that will be changing between an insoluble base and the soluble base is actually the states of symbols. Now, when we'll be writing equations, I think I'll show you. So we'll have this one now will be actuals. You'll find that nimeandika AQ somewhere. AQ, it is written AQ meaning actuals. And then for an insoluble, this one is for soluble. When it is soluble, we call it actuals, actual solution. When it is insoluble, you'll find that I've written hapo chini solid. So we write solid, of course, and then we close it with the opening and closing brackets. So you'll find that it is written as solid for the insoluble base. For the soluble or soluble one, base or alkali, we write it as aqueous. Very important. Now, the last process, which is direct synthesis. Direct synthesis means, just by the word direct, we are just doing it. When you're explaining to somebody, telling him, when you're moving from this building to this building, somebody is looking for a building, and then unamwambia, you just go directly. That is, you just go, you don't move in any other direction. You just go that direction. So this one is the easiest one, which is normally direct combination. You just bring, for example, I bring sodium, and then I bring chlorine, gas actually, and sodium directly, and then I put them together. Whatever comes out, the product of that process is the actual thing. So I'm going to, let me just wrap these on, because we'll be writing more today because of equations, and it is very dangerous for us not to know how to write equations. The other time I was telling you that it is better to know how to write the chemical formula and actually not the English formula of something. I don't know if, let me check. Yeah, okay. So I'm saying it is better for us to know how to write the chemical formula of a salt rather than writing the English formula, which is now we not the one that we use symbol. The chemical formula is better always. It is better because of what we call the ionic equation. I think we'll see that one. It is better to know than the English one. I normally use the English one because when I use other words, my students tend to ask, "Izo ni nini tena?" So English one is, for example, sodium chloride, the one that I have just mentioned, sodium chloride. But when you go to the chemical names, chemical names will be saying natrium chloride. So NaCl. So it is better to know for us to know the chemistry itself than the English itself, because it will help us somewhere. But in case you don't know, it is better to write again the correct English name. Iko sawa mpaka hapo? Now let us continue. So we preparation of soluble salts. So remember, when you talk about soluble salts, we normally, some of the times we use an example. We can use an example. For example, this one is an example. Now, this one is an example, but hapo chini will be saying we have others that can be prepared the same way. But the thing that will be changing maybe could be the acid. Because zinc chloride, this one is zinc sulfate. So if I want to prepare zinc chloride, I don't have to use sulfuric acid. I have to use now hydrochloric acid. That's the difference. But we'll see. So this one actually, sometimes they tell you prepare zinc sulfate starting from zinc and sulfuric acid. How do you prepare? I'll give you a question. We will try a question as we continue, and then we see. So preparing zinc sulfate. So number one, they normally give you dilute. So the things that you are given, or you'll be given the apparatus. You'll be given apparatus. Sometimes they tell you with name of the apparatus, which I pray they don't, because students normally tend to confuse apparatus names, especially when they're in R. So if it is better when they tell you starting from these and these. Explain now. So this one now is I have already, it is summarized about it. So you are given 20 centimeters dilute sulfuric acid, and then you put it in a beaker, and then you add now. And now the something about when you are preparing sauce, something that is very dangerous is if you skip a step, one step. For example, add put the liquid, which is now the sulfuric acid, dilute. Very important to remember that one. Dilute acid into a beaker, and then you add zinc slowly as you stir with a glass rod. So that number one is you add or you put the liquid, which is the sulfur, put the acid. Now let me use the acid in this case. Let me not say put the acid in a beaker. That is number one. Okay. So let me just for the sake of, so number one is you put this one in the beaker. That is number one. That is what you do. Number one. Number two, so you go procedural. If you write in paragraph, it's still okay, but it should be procedural. So that is number one. Number two, I add the zinc a little at the time while stirring. So that one is number two. Because sometimes you give 3 marks. So number two is starting from this place. So I'll just be cutting, yes, up. So you add slowly. These ones are marks. So you get a mark for putting the, of course, that is where the reaction will be taking place. And then you add zinc slowly as you stir. And then there's a reason. Students, most of the students could score the first 2 marks. The second now, where we are going now, is when they say add zinc until it does not dissolve further, or there is no effect, there is no effervescence. We normally say there is no effervescence. So you add the zinc in excess. That is number 3, or procedure number 3. So you start from putting the liquid in the beaker, and then you add zinc pole pole as you stir with a rod. This one you have time. We are assuming that you are doing a practical, so you'll be having a lot of time to do a practical. And then the solution you filter. For those ones who are not there, because I think we are many today, I said it is better to filter than to dry using by heating, or what we normally do at our homes, ya kuanika mahindi or something. So it is better to filter. Now I had said I hope I have the videos nearer today, because I had forgotten. But if I have the videos, I'll show you how filter paper is used, because we normally use it in the practical, especially the titration. So I'll show you how the filter paper is used. We can even do practically, and then we send clips. So I think that one will help us. So because it is very dangerous if you do not know how to use a filter paper. So you filter. Now, filter the filtrate, and then now you must, when you filter, you'll have what's called the filtrate, and then you'll have what's called the residue. So you must say you filter, and then what we are interested in. You can tell me the zinc sulfate now, because it is soluble, will be the filtrate. The residue actually will be the excess zinc. So we'll have the filtrate. Filtrate now will be so the filtrate will be zinc, the salt itself. Let me just write zinc sulfate. So the filtrate will be the zinc sulfate. The residue, because sometimes they will ask you, what is the residue? Ukifika the next question, they will ask you, what was the residue? So the residue is actually zinc, excess zinc that will remain. Because we want to ensure, that all the liquid or all the dilute acid is used up. So for ensuring that, or to ensure that all of it is used up, we must put excess. I hope we are okay. There's a reason why we put excess. They normally ask that question. And I remember, I don't know, it was in the last year's exam. I think it was in last year why we use excess, but it was not this question. It was, I think, copper 2 sulfate or something. So we have color changes that will occur when you're using something else. I'll tell you about color changes later on. Now, we continue. Kila mtu hayupo ako sawa. If you are not okay, please say. But I'll be explaining the processes. So it is very important. If you do not understand, it is very important for you uniambie mapema, so that I don't move. If I'm talking too fast, if I'm moving too fast again, please say. So that I naweka speed governor. So we continue. So we have dilute and then zinc. That is what is happening. So in fact, if you have enough time during the exam, you can do the drawing. So that I normally say drawing normally confuses the marker, because I'll be saying, even if you are wrong, now at least he or she had an idea. So it normally confuses people when you have a drawing, or it shows that you have depth of understanding, very, very deep. Depth of understanding will be coming in. So we have dilute. You put the acid first, and then you start adding zinc. That's what is happening here. Start adding zinc until in excess. So you add until in excess, and then you filter. You'll have the filtrate. Now the filtrate is the source. Let me just use SN, and then we have the residue. So yenye inabaki hapa. So because we are still helping ourselves, tunasaidiana, because basically you are from 4, so we tell you everything. The residue, anything that is solid that remains on top, whatever goes through the filter or through the filter paper and the funnel. So this one is the funnel. Now, I don't know if I'll be able to draw. So anything that does not have water of crystallization, it can be dried, because we are just extracting the salt itself. They are not saying, actually, kutoka hapa we already have the salt. We have zinc sulfate, but in solution form. So this one is zinc sulfate, but in solution form. If they want the dry one, so it will depend with the question. It will depend with the question. If the question wants the dry one, you're dry now. But it is not advisable. I'm saying again, there was a question, I think, in the year in 2024, 2023 or 2. The question was, why can't we dry using a Bunsen burner the salt that we have collected? So the reason is we want to maintain the water of crystallization ipaswi kutoka. Yeah. So we can so we'll have this one. I had mentioned this one. What is the name of this thing before I talk? Before I say, what is the name of that thing that looks like a plate? It looks like a flat plate. I had given an example of the Luminac dinner plates, those flat ones. It looks like that one. What is the name of that thing? Because they normally ask. I'll not give you the answer. So this one is heat. Actually, when you see an arrow and then you see a tripod stand, you know that we are eating. And then now you will get
Is it a crucible?
Crucible. I'll tell you the use of a crucible, but that one is not a crucible. Who answered?
Maura.
Okay, Maura. Maura, it is not a crucible. But I gave you the name. I want you to think about it as we continue. I'll still give you the name, but I want you to mufikirie tu. I gave the name previously, so we can continue. Now,
It's an evaporating dish, teacher. Is it?
evaporating dish. Yeah. They normally dance. Actually, what do you normally say? Ukifika hapa, I want to change my internet. But let us continue. I think I'll change it later on when I will be doing an assignment. I'll change the internet so that I don't stop teaching. Everybody can hear me well? Everybody can hear me, yeah? I'm seeing my internet is fluctuating, so I wanted to change. But if I change, again, we'll waste some time. So it is better for me to vumilia kidogo and then it goes through. I don't know what is wrong with my Wi-Fi today. It was good the other day. Okay. So anyway, we can continue. So we say effervescence stops when all the sulfuric acid. So there is a reason. They normally ask why do we add excess zinc? Yeah. So excess zinc ensures there is complete reaction. Actually, and so excess zinc is used to ensure that all the acid reacts completely. So the unreacted zinc now is removed, like I said, here, is removed as a residue. So it will be removed as a residue. I'm still repeating. Yenye inabaki kwa filter paper juu ni residue. We will talk about that one. We'll be talking about. So when we're collecting soluble salts, the filtrate is the salt. When we are collecting the insoluble salts, the residue is the source that we are looking for. I think we'll talk about that one later. So we'll talk about that one. So a saturated salt is the one that cannot allow. When you talk about saturation, we are saying it is a salt or it is a solution that cannot dissolve any more solute at a particular temperature. It is very important to talk about temperature. I'll ask you a question and then you'll answer. Now, let me just ask a question. When you are cooking tea, I hope everybody is actually African. African, I don't know, Kenyans, they're very good with tea. Now, if you're cooking tea, now weke sukari. I'll mix the language. And you add sugar, and the tea is cold, and the sugar is in excess. If you continue boiling, will the sugar dissolve in that tea? I talk about now, does the temperature affect solubility? Think about that one, and then we continue. So we continue. So a saturated solution, I'll repeat again, because it is not here. So now that the definition of a saturated solution will be done in salt, but the other salt is in form 4. That is the next topic after this. So you don't have to be worried. But I was just mentioning it so that if you figure the other side, at least you'll have an idea. So a saturated salt actually is or a saturated solution is a solution that does not dissolve any more solutes. Remember, the solute is the solid. The solvent is the liquid that is dissolving the solid. And when you combine a solvent and a solute in a form solution, by the way, so at a particular temperature, if it cannot dissolve any other solute at any other temperature, we say that one now is saturated solution, or it has reached the level of saturation. Very important. So the equation which I was talking about now, which is very, very important, is the one that is below. Now we'll write for this one, and people will post it on the wall. We are going to write one. Please allow me, muniandike tu moja. We'll talk about other salts that are prepared in the same way, and then you can do the equation. So we have, it is very important for me to highlight this upper. I want to highlight this one for the sake of understanding. Now, this equation is only correct because it has the zinc and the symbol of the zinc, which is the state symbol. At what state is that thing at that moment as it reacts? Is it a metal, which is a solid? Is it a liquid? Is it a gas? So that one is very important. plus, remember, it is dilute acid. So dilute acids are solutions. So it is aqueous. If I was using, let me just make this one very clear. If I was using concentrated acid, that is 98% of the acid before niongeze maji, before we add other things inside, I would have placed here as L. It is a liquid. When it is itself only sulfuric acid without anything else, that means you have not introduced water, we have not introduced any other impurity inside. It is a liquid. But ikiwa dilute, it is aqueous. Take note of that. When it is dilute, it is aqueous. When it is. Now, so of course the outcome now will be, we have now our salt, which is soluble. So we have the salt, and now the salt is soluble. That is why you are seeing the mandikaje. Actually, it has dissolved. It may dissolve. Yeah? So because it is soluble, it is aqueous. If we were making now another one, which is if we are preparing, of course, a salt which is solid, mungeona nimeandika something different. So it is very important. So this, for the equation to be correct, it must be having the symbols. It must be having the symbols. Without the symbols now, we don't know what you're writing. So it is very important. And of course, it comes with hydrogen. Very important. So, and the equation must be balanced. If it is not balanced, again, you get it wrong. But this one was self-explanatory. Other source that can be prepared in this method, through this method, or by this means, is magnesium. This one is not clear. I don't think this one is visible, so I'll write it in Tandika Ju. So you have magnesium nitrate. Magnesium nitrate. Magnesium nitrate. Of course, when you are writing this one, also follow the rules of writing the equations. I think that one was it is in Form 1. I think it will be, we'll still go through that one. It is very important. I think this one is one of the topics that I normally think if students can just know how to write this, then they are good to go. Very good. So we have magnesium nitrate. So we have magnesium nitrate. There are very many. I'll just write the calcium chloride, include as zinc chloride is here. There are very many. So magnesium nitrate, remember it is in 2. So you'll be writing it. That one is magnesium nitrate. So we have magnesium nitrate. We have very many salts. We have calcium chloride, zinc chloride. I've mentioned zinc chloride. I don't know. I think aluminum chloride is here. So those ones are some of the examples. Now, if I want to make the magnesium nitrate, I don't use the sulfuric acid. I use the nitric. So I don't know. Let us write for magnesium. Can people write for magnesium as we peruse for something else? I've given 2 examples. At least I'm saying, at least I told the students who were in the other time, we should know at least just know at least 2 examples. Especially, I was talking about the solubility of salts. We're giving at least 2 examples. We are talking about other things. I say you at least know 2 examples, because sometimes they tell you differentiate, giving examples. Yeah. So at least you should know at least 2 examples. Sometimes they will tell you, apart from, for example, they will say, apart from zinc sulfate, which other salt is prepared by reaction with dilute acids? So you can still mention and you say magnesium nitrate or you say calcium chloride. Very important to know at least 2. Unless there is a question, we continue. If there is no, is there a question? Is there a question? So it is very important for you to know those ones. Now, an example done. This one is an example, by the way. This one is an example. Explain how sodium chloride crystal can be prepared in the laboratory, starting with sodium hydroxide solution and dilute. So that one is one. That one is an example. They'll give you 3 marks. I'll have given 3 marks for this. 3 marks. 3 marks. So it is very important to know. So this one actually, the reason I normally give out this question, specifically is because of titration. Titration. It is a question that is done in titration. That's why we have the indicator. It is this one is something that we do in titration. They will tell you add 3 drops of phenolphthalein indicator, it turns pink, and then you dilute phosphorus until it turns colorless. So it is very important also to remember the colors of indicators in bases, acids, and neutral solutions. That one was done. So we have only 2 very important ones that we normally use in high school. 2 very important. Phenolphthalein, which if it is there in your exam, you are very lucky, because I normally say those ones are the easiest. Change from purple or pink, but it is purple. I don't think it is pink unless it is contaminated to colorless. If you pick a colorless that has reached now the endpoint, it will show you the endpoint. When you're given clean methyl orange is very expensive, so we do not normally use that one. I think colleges uses that one. Clean methyl orange is very expensive. High schools, no. So when you're given methyl orange, methyl orange is where the problem comes in, especially for men. Men will have a problem, and they can agree with me that we do not know the difference between uh, orange and light yellow or something yellow. So I still have a problem, and I teach now those things. So if you're in an exam room and they give you methyl orange, be very keen, very very keen. But if you are in an exam room again, they give you phenolphthalein, thank God, very important. So now these things I'm saying, purple, pink, it will be sometimes it is purple when it is contaminated, pink, or it is it may overstay. Sometimes when you're in the lab and it changes to purple, don't be worried. The endpoint still will be shown because the color will change. So sometimes we say so you pour indicator mpaka it disappear. When it disappears, that means it has reached saturation. The same case with the other one. When the effervescence stops, it has reached. So that one is the. I hope everybody can see the screen. Very important for you to see the screen. So you put it in a beaker, add 3 drops. That put it in a beaker is the first step or the first procedure, and then add 3 drops of phenolphthalein. Of course, now the other one, the end, the effervescence stops. But this one, how do we know? We don't have a way of determining that it has reached the end or it has reached saturation. So that is the function of the indicator. So you can use any indicator, any of them. We don't use a litmus paper here. Very important to remember that one. We don't use a litmus paper because it will be affected differently by the solutions. And the solution that is formed actually is not neutral. So that is why we use an indicator. So dilute, you pour slowly the containing sodium hydroxide and until the color disappears. So you unaweka pole pole. The same way we are adding zinc slowly stirring, we do the same thing here. We add slowly as we stir. Or you stir or you swirl. I don't know if you know swirl. Ile inaitwaje? Unapoisha chai kidogo, you zungusha the kikombe. Yeah, you do that. That is swirling. Huh? So you swirl. uh I don't know. Other people say it is swirl. But we swirl in Kenya. We swirl. So and then the color solution. You now evaporate the solution. When you evaporate the solution, because this one has all of them will be liquids, you evaporate. Whatever will remain is solid. Sorry, whatever will remain now, the crystals that will be formed will be sodium chloride. And you must tell us that you reach the end point and then you evaporate the waters that are formed, and then you remain with, because this one is basically a neutralization reaction. I think it will be there. It is down there. So the indicator shows when the reaction is complete or it has reached the end point. It is the same thing. If you end point, it will change color. That means the amount of sodium hydroxide and the amount of HCl are in equal ratios based on the mole ratio that we are going to write. Yeah. So they are in equal ratios. I'll tell you that one apochin. So our neutralization reaction, okay, that is it. Is the reaction between acid and a base. I think I had mentioned this one previously, and I mentioned this one and I said if there is an equation that is easy, right? It is the neutralization reaction. It is the easiest in chemistry, actually. you are not supposed to lose marks in writing the equation for neutralization. And what in fact in Form 1, the definition of a base is a substance that reacts with an acid to form salt and water only. Again, the definition of an acid is something that reacts with a base to form salt and water only as the only product. Actually, which I said that one the other day, and I said we do not use that one. I said let us say salt is something that or is a substance or is a compound formed when hydrogen ions from an acid are replaced by another cation or another positive ion, which I'll show you here. So I will see how it is formed. For the sake of those who are not there, I like everybody to be aware of what is going on. So neutralization, actually that one is a neutralization. But in neutralization reactions, you must add something that will show us the endpoint. Sio kama ile ya zinc na sulfuric acid, where the effervescence will stop. I hope everybody is clear. Now, how is the salt formed? I'm saying we are many. The other day, I think we were 4. So if we are 9, that means there's somebody who watched the video. But I think the video again was okay because the explanation is inside. But I think let us do this one. So this one is a base, and this one is the acid. So an acid has 2 ions. So it has the hydrogen and the chloride. So when we remove, I said yesterday, not yesterday, the other day, when we remove the hydrogen ions, which is positively charged, and then we bring another positively charged ion na iingie hapo pahali hiyo kitu ilikuwa, where the hydrogen was. Whatever is formed when hydrogen is replaced by another cation or another positive ion, whatever is formed when there is a replacement of hydrogen from an acid, any acid in that case, whether it is sulfuric acid, whether it is carbonic acid, whether it is organic or any acid, whatever is formed when you remove that hydrogen, which now is this, is now what we call a salt. So this one is a neutralization reaction. And I'm saying the phenolphthalein indicator will show us when the mole ratio of sodium hydroxide and the mole ratio of HCl, which is the acid, hydrochloric acid, is 1:1. So ikifika 1:1. Okay, okay. I'll give you something and then I'll change it. So when the color change occurs, or when there is a color change in the solution, the mole ratio is 1:1. I wanted to rub so that I can write 1 mole of sodium. That means if you have 10 liters of sodium, or let us use a value that makes sense. If you have 10 centimeters of sodium hydroxide in that big, the amount that you have added, the color ibadilike from pink or purple to colorless, or the pink color disappears, is 1:1. So if you use 10 centimeters cube, hapa pia itakuwa imefika ngapi? 10 for that color to disappear, or for that color to appear, depending on the indicator that you're being given. Very important for you to remember. And the color changes in indicators are different. And it is the good thing about the color changes in indicators, it is repeated. It is done in Form 1. I think we do it in Form 3 again. That one is in moles. It is done. So I hope everybody is okay. I hope everybody is okay. Actually, this is a reaction between acids and bases, which was one of the methods. Now we go to the last. I think this one is the last one in this category. So we go to the last one, which is let me just cancel this out. Everybody can still hear me very well, and they can see the screen. If you can't, you can share. If you can't talk, you can share on the wall again as we continue. Now, this one is the easiest method of preparation. Direct synthesis. Direct synthesis is what we call direct combination of elements. we combine the elements. I bring sodium and chlorine. That was the example this one is the easiest example that we use. Let me check, somebody has written something. Yes, okay. So direct synthesis, and if I'm moving too fast again, nimesema mtu aseme jambo. I don't want to move too fast. There's no need of anyway me finishing this and then you are stuck. Yeah, and then you are stuck. I normally say it is better for me to take the longest time explaining something, and you grasp that thing, the small thing, than as moving very fast. Ukifika mwisho, you realize, what did we talk about? Yeah, I think that one will be quite unfair to you. Yeah. So direct synthesis, again, I'm saying it is a direct combination of elements. We are bringing the elements, we know the elements. We studied the first 20 elements in the periodic table. So we are talking about those elements. I bring iron, for example, and then I bring another one. Those elements just that are there, sodium and chlorine, sodium, sulfur, those ones. I bring them and then I react them, I combine them. Whatever is formed is a salt. And these salts, so we have the examples: aluminum chloride, iron 3 chloride. I will not talk about these ones. I'll tell you where these ones will do it again. Iron 3 chloride, aluminum chloride, we will do it in form 3 chlorine and its compound. Itself, it has a special subtopic of itself, especially iron 3 chloride. So I'm not going to touch on that one. So other things, of course, when you're it is very important to remember that chlorine is poisonous. Again, that one will be mentioned in form 3. But because we are using this one, we'll talk about that one. So it must be done in the fume chamber. If it is not in the fume hood, which is the fume chamber of previously, we call it now the fume hood. If you cannot do it in the fume hood, because maybe the practical is being done in a smaller school that does not have a lab, I'll advise you to do it in the open air. So open air, there is no effect, but fume hood is the best. So it is just, now what I was talking about is this combination. So you just burn it together, you bring them together, and because the reaction is exothermic, it will produce a violet. Imagine this one is aluminium, which is not really reactive metal. So imagine as you continue upwards in the reactivity series. So I'm saying again, as you continue, please have the reactivity series in your fingerprint, because I think there was a question a few years ago where they were given a metal. For example, they'll give you silver plus HCl, and then they ask you, can it form silver chloride? Food for thought, by the way, food for thought. Gold plus chlorine, HCl, not chlorine. And then they ask you, what will be the product? Actually, there is no reaction. The answer was no reaction. But I know most students wrote it will form gold chloride with hydrogen gas, which is not possible because gold cannot displace hydrogen because it is low in the reactivity series. So it is very important for you to remember that. You don't have to capture everything; just have to know a few of them, and most of them we have mentioned. So other methods that can be other salts that can be prepared by this method. We have iron 2 sulfide. This one is iron 2 sulfide. That one iron. If it was iron 3, it would have changed the name. So we have iron 2 sulfide. This one is number 1. Let me just touch on them. So this one, iron 2 sulfide. We have sodium chloride. I think I'd mentioned that one. And this one is prepared severally. From form 1, we prepared this one. In form 2, I think we have to prepare in form 3, of course, it must be prepared because we have chlorine and its compounds. In form 4, we have okay, it is the same topic of salts and water. We'll be having what we call why is the name leaving? Hardness of water. And so we have methods of removing hardness of water. One of them we'll be using what we call ion exchanger, which is there. So iron 3 chloride now is here. This one is iron 3 chloride. We have potassium chloride. Direct combination. Of course, the fourth one, E. This reaction is explosive actually. very violent. Huh? Very, 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 very. So those ones are the equations. Remember, when you're writing an equation, it is very important for us to remember this. Again, I'll repeat. I don't get tired repeating. Make sure that you have written the correct symbols. For example, iron is Fe, sulfur is S, and you show if it is a solid or you must show the states. As you can see, we have solid, solid, and solid. This one is sodium, which is a solid. Then we have gas, chlorine, which is gas, and then we have, of course, the sodium chloride that will be formed will be solid. So it is very important for you to include the states. State symbols are very important. You must also know how to write the equation. How not the equation, how we write the compound itself. For example, sodium chloride is a compound because it has more than one element. So know how to write the elements. For example, F is the capital, E is small. Very important for I think that one is you already been told, but I'll just be touching on those things that will help you to kiendelea. Now, so we are done actually with the soluble salts. So soluble salts are the easiest to remember, and they are the easiest to handle. What you are supposed to know only is to follow the procedure. Make sure you are fikiria tu before you write the answer. Unasema inaanza wapi wapi as you continue. So that is very important. We continue. Preparation of insoluble salts. So insoluble salts, number one, you're already done with that one. So we can prepare by direct synthesis, which you are already done. For example, one of the direct synthesis is preparation of iron 3 chloride, which is there. This one. So this one is iron 3 chloride, so it has been prepared. So that one is okay. And then the one that we normally use now, not in the lab, is double decomposition or precipitation. This one is the same like the first one. You remember the one that I was saying, the filtrate and the residue. In this case now, we'll be having what you call the residue and the filtrate. The filtrate, we don't care about it. We just throw it away. But now we're interested in the residue. So let us go now to precipitation reaction. I hope everybody is okay. I hope I'm not moving too fast. And if you have a query, I'm saying again, still post it on the wall. If you can raise up your hand, the better, so that I can just answer it directly. Just give you the answer directly. Now, so we have what we call I want to repeat this one. I told this the people who were in on, was it Saturday? The precipitates. Don't write. I know some people have been writing PPT. Actually, PPT is has a lot of meaning. But maybe you could be talking about PowerPoint. Uh, but I don't. We assume that we don't know what you're writing. Yeah. So it is better to write in full precipitate. So a precipitate is an insoluble salt formed from actual solutions. So anytime now I have to explain this one, especially practical, using the practical. That is not as clear as water. I repeat that one very slowly. Anything that is formed that is not as clear, anything that is formed as clear as water, yes, actually is a precipitate. Ikiform tu kitu inakaa I know, let me just explain using this one so that it becomes easy. Ukiweka, when you remove milk from the sufuria that was boiling milk or that was cooking milk, alafu usioshe na uweke maji, the color of the water would not be like the water that you're pouring in. Yeah? So if the color of what you are doing, uliweka kitu ilikuwa inakaa clear, and whenever you get sio clear vizuri, yeah, let me just use that. Sio clear is not like when you, before you introduce that substance or that liquid, that new liquid. If you see anything of that sort in the lab, you say it is a white precipitate formed. That one is what I wanted to say. Precipitation is the formation of solids, of course, from aqueous solution, formation of solids. Now, the reason why we had gone back reminding ourselves of the insoluble salts. I want you to insoluble or the solubility of salts, which in that case you're talking about lead sulfate, barium sulfate, lead chloride, silver chloride. The reason we're talking about that one is because now of where we are now. Yeah, because tukifika hapa, I want you to remember somebody might hapa we will not be talking about something, but for us to prepare lead to an insoluble salt, we must have two soluble salts. So we have two actual solutions being combined even before we read that. So for me to form, for example, a two sulfate, I must be having two soluble salts or two actual solutions being brought together, and the outcome of that one must be an insoluble salt and a soluble salt. Very important. So when we are preparing, again, let me just repeat that statement very slowly. When we are preparing insoluble salts using the precipitation method, you must have two you must underline you must be using two soluble, two of them, two soluble salts, but the outcome must also be a soluble and an insoluble salt. That's why I had to mention the rest. Now, so we can do an example. We have the two sulfate. Now, I think I'll do this one. So they will tell you starting from, they'll tell you that one. By the way, I'll give you a question. I think let us just use this one, and then we'll do another one. I think that is okay. Starting from the nitrate solution and magnesium sulfate solution. Prepare lead two. Prepare lead two sulfate. So procedure number one, of course, sometimes. Now let me tell you something about the procedure. This one was actually a practical session that was being done. Like the students were in the lab and then we are preparing. So that is why this one was factored in. But you don't have to factor in the amount. You just say add lead two nitrate or put lead two nitrate into a beaker. Yes. Alafu, you don't know, the problem comes in. The students normally say, so you have added into a beaker the lead two nitrate. So the students wanawacha hivi, wanasema add excess magnesium sulfate into the beaker. So we don't know which beaker you add. Actually, you should say to the same beaker add magnesium sulfate. So it is very important for you to mark that, please. So add, and then you stir, add magnesium sulfate and stir in excess. And then after we have stirred, we let the solid settle. Now, after settling, I want you to see something I've been mentioning from when we began. You can, this one is a method that is normally done in, if you don't have filter papers, you can use this. So you can just decant, and then now the residue is lead sulfate. The filtrate, I'll still explain that one. The residue is the solid that will remain uko chini. For example, ukiweka sand, if you put sand in water na wash it, and then you pour the dirty water, there will be some particles that will remain inside. The particles that remain inside the basin, or that remain inside after you pour the dirty water, is the residue. The poured now water is actually the filtrate. The liquid is the filtrate, the residue is the solid. Very important for you. And then you can wash, so the solid is washed with distilled water, because maybe you are washing to remove any other particles that could be there. If you want the very clean one or the pure, let me use the English, the chemist word, pure. If you want the pure one, you wash with distilled water, and then you dry with filter papers, or you can still do what? Anika, But I'm saying dry using Bunsen burner or dry in the sun is actually not the best method. Of course, you score a mark, but I'm saying it is not the best method because now, if you say you dry in the sun, what about people who don't have sun? Because I know some places that do not receive sunlight. So that is why we use something that is available. Now, so we continue. Yeah. If I take too long explaining na mumeelewa, you tell me, please move. The other one is still in order. So we continue. So explanation. So the procedure. Now the procedure is very dangerous because they normally say starting. I'll give you a question. You'll write and then somebody can explain as we continue. I'll give you some few, maybe 2 minutes to explain how that one is done. Yeah, I'll give you 2 minutes. And then it will be open for if you want to speak, if you want to type, well and good. I think I'm open to any method that we use as long as you're getting the information. I think that one is the most important part of it. Now, so explanation, when you add lead nitrate, magnesium sulfate. Now, remember, I want you to us to remember something. All nitrates are soluble. And then when you come to sulfate, the insoluble sulfates are kina, lead and barium. So magnesium sulfate actually is soluble. So we are mixing two. Remember the condition that I gave. You must be having two soluble. So lead to nitrate, all nitrates are soluble. So lead is soluble. Magnesium sulfate, the insoluble sulfates are very few and we know them. So a white precipitate is formed. The lead ions and sulfate ions that form an insoluble salt. Alafu, the other one now that is formed, which is magnesium nitrate, is soluble because all nitrates are soluble. So we call this now double decomposition because everyone wants to take the magnesium wants to take the nitrate while the lead or the lead wants to take the sulfate. So that is why we call it the double decomposition because of ion exchange. We are changing the ions. So this one is actually the chemical itself, the chemistry itself now that is taking place, not the chemicals. The chemistry itself that will be taking place, we'll be combining lead to sulfate. This one is the word equation, which I don't really care about people knowing this one. This one is just a direction. But the pali tunataka is this one now. This one is where I want us to be. Up. So you have the lead nitrates. As you can see, this one is aqueous. Now, an aqueous solution means it is soluble. Now we have another aqueous solution, which is magnesium sulfate, because actually magnesium sulfate is soluble. All sulfates are soluble except barium and lead. Now all nitrates are soluble, so that is basically why. Now, as you can see, the lead sulfate now form is solid, while the other one is what? Aqueous. So it is very, and of course, another rule that you are supposed to know when you're writing equations, chemical equations, wachana na word equations. This one is the word equation. This one is the one that is taught in Form 1. This one is the one that is taught in Form 2. So the word equation, there is no problem. Most of the time, of course, I'll give you the word equation and tell you, write for me the chemical equation itself using the symbols now. So word equation, there is no problem. So you must show again. So that is why it is. This one is the right perspective. Remember the condition that I had given. Remember the condition that I had given for writing equations. You must show the states. You must know the state symbol of that particular metal or that particular element that you are writing. It is very important to know the state symbol. You must now include the states. You must include the states of the solid or the states of the solution. If it is aqueous, if it is a gaseous state, if it is solid, if it is liquid, you must include them. And remember, Nilisema, when it is an acid and it is dilute, it is aqueous. When it is liquid, it is concentrated. It is very important to differentiate the two. Now, so you can write that, and I'm saying, when after writing the equation, you make sure that it is balanced. If it is not balanced, that means you count the number of PB and the PB, the reactants of the product side, they must be equal. Now, this one, writing these ones now, well, after you have done that one, you know how to write these equations. Anytime the states that we know are formed or is formed, anytime that we form a liquid, a gas, and the solid, it will give us something called ionic equation. That is why we are in ionic equations. Even before you do something, before I give you another thing, I want to give you the ionic equation. So ionic equations, actually, how we write ionic equations? I normally explain ionic equations this way. Anything that is aqueous. Now let me explain using this one before I continue, before I go down there and explain. Anything that is aqueous, that is like this. Before we go to the word, to the words, I think let me just explain using my own words, which I try to summarize. Anytime you see this E na E, you can separate them. Actually, you separate the ions. You put lead ions on this side and nitrate ions. That means I can cut this on this one. That means I'll be having lead. And remember, lead ions has 2 positive. I'll have that aqueous, and that of course nimesema ni aqueous. So you show plus. I'm separating this one. Let me just separate this one though. So we'll have plus nitrate ions, which is normally NO3 with a negative, 1 negative. So sulfates have 2, carbonates have 2 radicals. I remember we talked about radicals the other time. So please go through the radicals and the valences. Know the radicals and valences. Very important. So we have aqueous. So these ones, and remember, these ones are 2 from the equation. So unaongeza 2 up. Now, this one can be separated. These ones that have aqueous. The ones that have solids, if this one is a solid, if this one is a liquid, and if this one is a gas, you do not separate. Don't touch it. The rest that are separated are in aqueous state. But if you have the 3 states of matter, which is the solid, the gaseous state, the liquid state, please do not touch that one. Wacha ikae hivyo. You don't cut this one now the way I was cutting the other one. Inabaki hivyo. So we cut this one also, it is cut. You separate. This one also is separated. Very important. I wanted to say that one. So let us go now to actually this, and then we can. I hope you have understood. So that when we'll be doing the words, please you have an idea of what is going on. So let us continue. Ionic equation. So what is an ionic equation actually? Yeah. So are equations obtained by writing only those equations that undergo change during a chemical reaction. These ones that undergo chemical change. So upper, this one was aqueous in this place. Actually, it was aqueous. Alafu hapa pia sulfate is aqueous, but ikifika hapa inakuwa nini? Solid. So the change has occurred. So when the change occurs, those ones remain. We do not separate those ones. Magnesium ions, actually, and nitrate ions are aqueous in both sides. I want you to see. Hapa magnesium is aqueous. Hapa pia magnesium ni aqueous. Hapa nitrate was aqueous. Here pia ni aqueous. Those ones now are called what we call the spectator ions. So the ions that remain unchanged during our chemical reaction are called spectator ions. And most of the time, we normally omit them or we remove them when writing ionic equations. We cancel them out. Now, an actual state, of course, you should know. So the ionic equation for that reaction will be lead, which was aqueous, combining with sulfate ions, which was aqueous, so that we have a solid. The other ones, we remove it. We remove the aqueous, we cancel them out. I don't know if you have understood, but we're still going to write more. I'll give you one so that you can write. You will write one. So writing steps in writing ionic equations, I think we can just explain using the longer one. So of course, number 1, We write the chemical equation. That is why I was saying it is very important to know the chemical equation rather than the word equation, because it will help you here now. That was the first statement that we made when we came in. So it is very important for you to know how to write the chemical equation. This one is the chemical equation. Number two, now separate, which is the same thing, dissociate, English, a lot of terms, but meaning the same thing. Because now the good thing about chemistry is I don't mark the language. I actually mark you having an idea of what is going on or knowing what is going on. So you dissociate the salts in nitric acid because they are free ions. Yeah, that's what I was saying. You only separate those ones that are active because of their ions that are free, or they have ions that are free. The statement that I've mentioned is, or that I've just said, is the same. We have mobile ions, which are in the actual state, and then we have aqueous solutions which have mobile ions. So there's no problem. So those, it is very important. Those in liquid, gaseous and solid states, I just mentioned that one, have no free ions, and so because they are not free, that means, or let me just put it this way: solids, liquids, and gases are not free, just like that. So we leave it as they are. We don't touch them. This is what we are saying. So we separate now. So to Mandika the chemical equation, which was correct. Now, for these things to be correct, for any equation to be correct, mind you, let me just mention that one. All on both sides, they should be neutral. I mean, when you add the ions on this side and the ions on the left, the ions on the left and right, they should be equal, or the ions on the right and left, depending now on where you are now. So the ions on this side, where the cursor is, I hope you can see the cursor. The ions on this side should be equal to the ions on this side. That thing should have a charge of 0. I mean, the reaction should have a charge of 0. You will see. I'll show you somewhere. We'll see as we continue. So the solids, liquids, and gases have no free ions, so you don't touch them or you don't break them. You don't separate them. It's in a bucket when it's equal. Now, so this is what we are talking about now. So the lead ions, we have the lead ions, which are two I. Remember, there are two positive. We have the nitrate ions. Remember, it has also 2. So it is -1, but how many are reacting? 2. Yeah. And then we go to magnesium. Magnesium ions are 2 positive. And then we have sulfates, which is 2 negative. I want you to see this one. What is 2 positive plus -2? It becomes 0. 2 positive plus -2, again 0. So the overall charge on this side now, these two sides, the reactant side, let me say the reactant side is 0. Let us talk about the product side. So as you can see, actuals and actuals, we separate or we dissociate. The same thing. We ionize, or we can say dissociation is the same as ionization. So we ionize those things. So as you can see, tumeifanya ionization actually makes, so we are saying we are making them be ions. So tumeifanya ikuwe ions. Now, the ones that are solid, nimesema zikiwa solid, I'll repeat again that one because it's a very dangerous one, because I know we can do something that has liquid. If it is a solid, if it is a liquid, and if it is a gas, you don't charge them. They remain as they are. Hata kama ni sulfur 4 oxide gas, wachana nayo. Now, so the lead sulfate remains as solid, and then we dissociate the others, we ionize the others, we make them ions. So we have what is 2 positive plus, this one is nitrate is 1, but 2 nitrates are reacting, so each one is bringing 1 negative, so inakuwa 2 negative. What is 2 positive plus 2 negative? It becomes 0. So the right hand side, or the product side also, is neutral. So I'm saying the universal charge of a reaction that reacts and product to produce 2 things actually is neutral. The chemical equation, all chemical equations are neutral unless otherwise stated, or the equation is unless otherwise stated, or you have not balanced the equation. And when you don't balance the equation, it becomes automatically wrong. Equals our. Now we go to procedure number 3. So number 3 will be like this: those ions in aqueous state appearing in both sides. That means you have aqueous on left, that is on the reactants, and we cancel them out. And this one now are cancelled out and they are called spectator ions. These are ions that are there in the reaction, but they do not take part in the reaction. They don't change. When you don't take part in something, that means you're not changing. For example, if you are in a place, if you're in a meeting and you don't, or let me use, I think most of you go to church. If you don't, there's no problem. Wherever you go, mosque, when you go to that place of worship or your place of worship and you don't do anything, you don't sing, you don't preach, you don't give out sadaka, you don't do anything. You are just there to fill the seat. You are spectator. Yeah. Or I can, another example is I think men are affected by this a lot. The football fans. The football fans watch. So when you're watching, you can't do anything to affect the game. There's nothing you can do. You could be having ideas of how they could have scored or something, but you don't affect how the pitches or the players in the pitch are doing. So that one. So because you don't change, and you can't score, you can't give out sadaka, you can't do anything. You remain the same as you entered and as you leave. There's not. You didn't even shout. We are removing you because you are nothing. So that is what our spectators we do. We remove. We cancel those that are actuals on the reactant side and actuals also on the product side. They are cancelled out. So you cancel. Whatever remain now after cancelling out all those ones, whatever remains, which is this now, we say this one is the ionic equation. Sijui kama tumeelewa, but I feel that we are okay. Other salts that are prepared by dapotic compositions of could include those ones that are insoluble. Because those ones that are insoluble, we have things that are insoluble, silver chloride, copper 2 carbonate, we have lead iodide, barium sulfate. Now, this one is what I was talking about. I want you to please, I'll give you only 2 minutes. We are very many. I don't want to choose who is who. Let me say, for the ease of handling these questions, let the ladies do question number 1. Those ladies come first, and then the gents. Let's do question C. I'll do question. Which one? All of them are very easy. Okay. Let me do question B. So you do A. The ladies comes first. I've already given you the equation. What I'm looking for, actually, I've given you the equation. Most of the time, we don't give you the equation. So I've given you the what is here. Let me just do it. So I'll give you, this one is actually the equation. Unaona zenye ziko nimeweka hivi. The ones that I've unlocked. Sorry. Don't mind that one. So the ones that I've unlocked are actually the equation. Sulfate is for the ladies. Copper 2 carbonate. It is copper 2 carbonate. The gents. You can write it on the wall, or you can just unmute yourself. I'll mute myself for that one, and I'm giving you only 3 minutes because it is 9:22. For by 9:25 it should be done. Then you proceed to something else. That is in order. I hope that is in order. I want to see if we are proceeding very well. That is only that is my request. Please let us do that one. I'll mute myself for the 3 minutes. If you want to speak, you just speak. I'm gone. 3 minutes. have 1 minute. If you're done, again, you can just tell me that you're done. I'm really interested in you understanding this.
Teacher, you've said for the ladies, the one with sulfate.
Sorry, barium sulfate is for the ladies. That is the first one, A. I'll do B myself, and then C is for the gents. So at least gents will be doing 2. Because of I fall under their category. Time done. I will continue so that people can post their answers. What do we do? Yeah, nobody has posted anything. Nobody has. I'll do mine, but I'll do mine. Yeah, I want to do it on the question because of time. We are remaining with very few minutes, and I wanted us to complete this one. I wanted us to complete this topic today, hopefully. So you will be posting now. Because of time, you post. You post on the. I'll do mine. Yeah. So lead iodide. Actually, we are saying lead iodide is the one that is insoluble from the equation. The equation has given us. So this one is aqueous. Lead nitrate is aqueous. So we'll cancel out the nitrate. We'll cancel out the sodium because sodium is so this one will remain because it is solid. We cancel out also these ones and these ones. So the two of them, sorry. Yeah. So what will remain for my case now? It will be lead. Now yangu nimepitia shortcut. You don't have to do that. You dissociate, like you ionize them. You make them ions. You ionize them. So lead 2 ions, actually. So you must show if it is actual though, because that one is very important. Plus this one is the ionic equation of B. Actually, let me just put B plus iodide ions, but there are 2. Remember, there are 2. So 2 iodide ions negative. Of course, you remember that group 7 elements. I think that one is another topic in Form 2, which is quite dangerous. I wish that you had thought that one before even we came to this one, but I think it will be the first topic because these are actually the first topics of. But salts, we are doing salt because it is a combination. We continue from Form 1, Form 2, Form 4. Yani ishe tuende hivyo. If we are doing organic chem, we do organic 1, 2, hivyo iishe the same time. Ndio ikukuwe na continuation. So this one will produce. So this one again is aqueous. Don't mind that one. If I was using a whiteboard or a chalkboard, it would have been much. Now I'm using the cursor. My laptop is not a touch screen. It is. I'm using the cursor and the button, so it is becoming something wiring. So it will produce now the lead iodide. Remember lead iodide. Lead is 2 from 2. So remember when you're writing equations, these 2 will come to this side, and this 1 will go to the other side. So that is why it is like this, and it is solid. And this one now is my ionic equation. Actually, just like that. So I think before we end, somebody will post there. Or you can, if you want again to do what I'm doing, I'll just allow you to do it. I think you can edit on the other side. If you cannot, you can annotate. There's no problem. I think it will still give you the same outcome. Now there's a query. I can continue. Can we continue? And then people can, you can give the answers later on. Because of time, I don't want us to stay on the same thing for a very long time. And we still have a lot of work. So, any query? The only remaining parts are around 3. We are remaining with the properties of salts. That is the exposure to air. And then the action of it on salts. I think so. And then the uses of salt. With the uses of salts, basically we just mentioned. So, yeah, in an issue. So, are we okay? Can I continue? You can leave that on. You can do it before the end. If you can still hear me, or if you can see the screen, the better. So properties of salts. I don't know if everybody is okay. Because now somebody, if you can, when you're not okay, you still can mention it. Now, so the properties of salts. The properties of salts. I think this one was there in last year's exam. I think this one was there in last year's. I don't know. I can't remember very well because I've not seen that paper. I've not gone through the. Actually, I've not gone through the theory. But we have done with the form first. With my form first, we have done the practical. We have repeated the practical twice. Where I changed the first one we used phenolphthalein, which was easy, and then the second one I introduced methyl orange. I wanted only to test the. They didn't even realize that it is the same paper because of changing only a few students could realize that it was the same paper. The only thing that was changing is the color. So most of them did not realize. Anyway, properties of salts. Now, the properties of salts, actually, we're talking about the exposure to the atmosphere. What happens when you expose salts to the atmosphere? There are 3 properties that will happen, or there are 3 things that will happen when you expose salts to the atmosphere. Number 1, that thing could acquire water. Before we go to the, I'll not follow this one. I'll just mention them for the sake of, but we'll read it. So number 1, it will acquire water. Now it form solution. That is number 1. Number 2, it acquire maji, but it will not form solution. So it will only take in water, but it still become solid. And then number 3, it will lose water of crystallization. That one is number 3. So those are the major. And now the losing of water, it has a process. And the process will give a name. Now let us start. Hygroscopic salts. We have what we call hygroscopic salts. So these ones are salts that absorb water from the atmosphere but do not dissolve to form solution. That was the first one. So it will not dissolve to form solution. So its process, the process now is called hygroscopy. That is the process of absorbing water but not forming solution is hygroscopy. The salts I call hygroscopic salts. Now, that process, so some of the examples, we have a lot of examples in that one. But I said, please know at least 2. Yeah. So we have now it is very dangerous. I'm normally afraid to give out now during the previous lesson. I'm not seeing somebody. There's somebody had I don't know wale walikuwa. Do you remember me telling you the test for water? Test for water. Test for water. The reason I didn't answer, I had not answered that question, but we were supposed to start with it today. So test for water, we normally use 2 things. We use anhydrous copper 2 sulfate, which it absorbs water to change. So it is normally white. When it absorbs water, it forms a blue solution. Now, another method I want to tell you only hygroscopic salts are those salts that are used to test for the presence of water or to test that this liquid is water. Because sometimes you go somewhere and you are like, is this really water? So come out doing Imaji, you can use that one if you have them. But most of the time, I don't think people will trick you to take something that is not water, unless of course they have ill intentions. So another one is anhydrous cobalt 2 chloride, which is also used to taste. It is normally used to taste if a liquid is water, and it normally changes from blue to pink. I had told the students, no, I told you previously, for those ones who are there the other time, that the color changes are the same. We have one color change, white. So it is very easy for you to know this one. It is normally changing. If you start from copper, it will be white, blue, and then you can write in the middle. You put. Let me show you how you normally teach them. So that it becomes very easy. So I put W, that is white, and then I put blue, B for blue, because I white. So and then I put pink, P, P for polythene, and then we have B for boy, and then we have W for white. That is white. So I put copper 2 sulfate, CuSO4 for the students. It is very easy because sometimes they ask you the color change, CuSO4. So you CuSO4 will go that way. Alafu naweka hapa chini. The cobalt. Cobalt is normal CO, yeah? I think it is CO, Cl2. So that will be changing. So it is very easy for you to remember. We have white anhydrous when it is dry. Anhydrous means dry. It is white, and then it changes to blue when you add water. Cobalt 2 chloride will change from blue to pink. Very easy. It is very easy. That is test for water. So other things that normally have that property of acquiring normally acquires water, or it absorbs water, but it does not form solution. Nikena magnesium chloride, aluminum chloride, potassium nitrate, and of course chumvi ya nyumbani, yeah? So the normal salts, the normal salts, those ones. So hygroscopic salts absorb water but not form solutions. Now, what about those ones that changes into liquid? What do we call them? So I had given three of them. I had said one absorb water but not form solution. That is hygroscopic. What about the one that will absorb water and form solution? That is the second one. These are salts that absorb water from the atmosphere and dissolve to form a solution. The liquescence is the process in which a substance acquires water, or process in which substances absorb water and dissolve in it to form a solution. So the process of forming solutions, very good example, copper 2 nitrate. Copper 2 nitrate is a very good example, by the way. Calcium chloride also, of course, has the same issues. Zinc nitrate. If you cannot remember these ones, remember to nitrates. Most of them are nitrates, because remember, all nitrates are soluble. So most of the nitrates that you would mention, most probably, will be having this issue. Yeah. So because of the solubility of nitrates. So copper 2 nitrate, calcium nitrate, as you can see, most of the chlorides also are there. Zinc nitrates. Now, when we talk about, you can try this one if you have potassium hydroxide, because I know most people don't have potassium, they have sodium hydroxide. You can try sodium hydroxide. Sodium hydroxide is very soluble. Ukiwacha, you don't even have to leave this one for a day. You have to leave it for a few minutes. It will dissolve, so it will absorb water from the atmosphere and so. But these ones now are bases. That is why nearly skip a line. So these ones are bases, easily bases, but these ones are actually salts. Some of them could be basic, some of them could be acidic. Very important. But these ones are actually bases, non-bases, very common bases in the lab. So the liquescents, they form liquids. Hygroscopic, absorb but do not form liquids. Now the last one, efflorescent salts. I think one of these ones was there in the PCC. I remember somebody gave me a hint that it was there. So efflorescent salts are salts that loses water of crystallization, a salt that loses water of crystallization to the atmosphere, a salt that loses water of crystallization to the atmosphere. The process of losing water of crystallization to the atmosphere is efflorescence. So the process of substances losing water of crystallization to the atmosphere is called efflorescence. Examples are those that are hydrated and are given hydrated salts. For those who are there, we wrote some hydrated salts. One of them was sodium carbonate. We wrote those ones that have hepta. For the sake of those ones who are not there, kumbe ziko hapo chini. There's no problem. So we have sodium carbonate, water. We have sodium sulfate, and then we have iron 2 sulfate. Those ones that have water. If it has water and then when you expose them, it loses that water. Those are now are called fluorescence. It is a very easy one. So the liquid become liquid, hydro no liquid, and then the fluorescent is the one that is in the opposite direction. But the rest, the liquid means it becomes deliquified or it becomes liquefied, and then hydro it only agro. I don't know. Hydro is water, so hydro it acquires, but it is not affected by it to completion anyway. But it can acquire water or it can absorb water. So those ones are, I hope you've understood. A very dangerous place. This dangerous place is normally repeated. For example, carbonates will repeat it in carbon compounds because it is falling under carbonates. Sulfates will be repeated in sulfur compounds. Which other one? Nitrates will be repeated in nitrogen in its compound. So all of them will be repeated. So there's no worry. If you didn't capture something, it will be repeated the same process. Nothing changes. This thing is normally repeated around 3 times. This one. In fact, we normally repeat it even including when we are teaching organic chemistry. I think we just mentioned something of the same. So actually of it on carbonate number 1, NB. Potassium and sodium carbonates are too stable and they are very, very stable. That's like that if you eat them even up to 1000 degrees Celsius, there's nothing that you'll get. So they are not affected by heat. But only when they have water of crystallization is when the water can be donated. So the water can leave. Because water ikishafika mia inaenda. Lakini now the carbonate itself not affected. So sodium and potassium carbonate not affected. And then this one again is normally sodium and potassium carbonates again are affected differently by heat when you are talking about the nitrates. I think that one we'll talk about that one. Now, so potassium and sodium not affected. If they have the water of crystallization, which is sodium carbonate, having water, deca, now the deca, the 10 waters will be taken or will be evaporated or will be removed. Other carbonates will decompose now to form metal oxide and carbon dioxide. Remember, when we're talking about reaction between metal carbonates and hydrocarbonates, niliongelea hiyo. I think I touched on that one. I touched on formation of CO2, so it will form that one. Those ones general equation is metal carbonate, you heat metal oxide and the examples, calcium carbonate, for example, form calcium oxide and CO2. The same. So nothing is changing. Now, and of course, remember kitu niliwaambia tena I think it's a few minutes ago. The reactivity series of a metal affects actually how the metal will decompose. Is it easy or very hard? Because now you see the first two elements that we talked about, which is potassium and sodium, they're very reactive. But as you move down, the reactivity becomes easy. Down the reactivity series, the ease of decomposition increases. That is what I can say. It is easy to decompose wale kuko chini than wale wako juu. That's what I can say. The only special case about this one is normally the ammonium carbonate, which decomposes to produce ammonia. Because again, the CO2 is present and water because of the hydrogen. So this one is the only one that is in special case. So I'm repeating this statement, but now this one is written here. The higher the reactivity of the metal, the harder it is to thermally. So the heat, thermal means heat to decompose. So hydrogen carbonates decompose again, they will form the carbonate. Now, because of hydrogen, water. Remember, I want you to remember maneno ya sodium carbonate. The others now will produce an oxide. But remember, sodium carbonate is stable. So once it is formed, the heat cannot further decompose it. So hapo ndo mwisho yake. But the others will decompose. Tuko sawa? Of course, those ones that exist. Remember, kuna pahali tuko tumeongelea, by the way. When you're talking of, was it solubility? When we talk about solubility, we say there are some that do not exist and they do not exist. So we don't have. So the others will decompose to form the oxide, CO2, and water. But the special case are the upper one. I hope you understand. If I'm moving too fast, I wanted to at least complete this one today. I hope we can finish it. But remember, you still have my question. So you still answer for me that one. Action of it on nitrates. So all nitrates decompose on eating. First of all, that one is very important. All nitrates are soluble. Again, all nitrates are decomposed on eating. The other one was special case. Carbonate is so all of them decompose on eating. The only decomposition now, the only difference that will come in is the decomposition style. For example, the first two that I just mentioned will decompose to form a nitride and oxygen gas. Nitride. This one was there in the KCSE of 2023. 100% sure it was there. Like I said, I've not seen that the other exam, so I'll not talk about that one. But I think somebody had seen it. Somebody, I think Maura knows it. I don't know if it was there. So nitrates of respective decompose to give a white residue of nitride, a colorless gas, and that colorless gas. I want you to remember when we talk about gases, I want you to remember the test for other gases. For example, oxygen relies a glowing splint. Hydrogen burns with a pop sound. CO2 forms a white precipitate in lime water. It is very important for you to know those ones because sometimes they tell you to give. Now, there's another gas that has the same property as oxygen. That it relies a glowing splint. Mutaniambia ni gani? Just think about it. It relies a glowing splint. We have I think nitrogen gives negative results in all the tests that are used to test common gases. So we continue. Other metals now. The other metals. So nimesema nitrogen, like I said, sodium and potassium have a special, they're different. They have special reactions in both the nitrates and the carbonates. Others now will react to form a metal oxide, nitrogen peroxide, and oxygen gas. So those ones, a nitrogen gas is normally brown. Nitrogen peroxide gas is normally brown. We'll talk about that one only in nitrogen peroxide. Nitrogen and its compound. Sorry, nitrogen in oxides of nitrogen, it is nitrogen peroxide. One of them is nitrogen peroxide. So those ones are the equations. Now, the important thing about this one is number two. I don't have a problem with the other ones. Is number two, which you have zinc carbonate and lead. Not zinc, zinc nitrate and lead nitrate. This one. I must talk about that one. E and this one. Where I want to talk about is this one. This question was there again. There is a class that they were given this one, and they were told the solid form is yellow and hot. Name the ions that are present in that particular salt. So the person was supposed to say the ions present is zinc. Because now they have given you ion that it is yellow when it is hot. They didn't say anything else. Otherwise, most of the oxides are either black or white. The special case of zinc, you must know those colors. So it dissolves. So in fact, today I was not talking about that because it will be mentioned in another class again. I know we are going to mention that one again somewhere. So it is yellow when it is hot, zinc oxide, and then white when cold. And these things are very easy. Actually, for lead, it is the opposite. You find yellow when it is cold, but only the color will change. Orange and yellow for men, it is the same thing. So there is no problem. It's understood. It is the same thing. I think ladies are fairly good with colors. Kutushinda. I hope everybody is okay. So the decomposition is different, but all of them decompose. So sodium and potassium decompose differently. The rest now decompose the same way. Yes. Now the only special ones also in nitrates, they can. I normally use mercury most of the time. Mercury normally decompose to give now the metal, which is mercury, and also the gas, which was nitrogen peroxide, was it is a nitrate and oxygen gas. So those are the special ones. These ones are the special ones. In this case, the bottom and the so as you can see, the use of decomposition again depends on the reactivity of the metals. The lower the reactivity, ikiwa huko chini, for example, yenye iko chini ni hawa au wawili, silver and mercury wako huko chini, so it is more easier for them to decompose and even form the metal. Ile ingine ikisha bond, ikisha kutana, which is bonding, it is very hard to break those bonds. It becomes very easy. Very hard to break those bonds. But ukiwa huko chini, it is very easy. Very, very easy. Quite easy. Of course, ammonium still remains, ammonium nitrate is still the same. Confused as always. This thing is normally confused, by the way. In all equations that you will write, you will find ammonium is confused, so it will form water. And now this one is the one that I was telling you about, nitrogen 1 oxide. I want you to find there is one oxide, but I think we mentioned that. Let us just talk about that on another time. That have the same property as oxygen. Say this one is the last one. Action of it on sulfate. Say this one is the last one. Yes. So actually these ones now metal sulfates are much more difficult to decompose, and so they are not really affected. But on strong heating now is when they can be. Okay. So we talk about sulfates. So now we increase that one. Instead of using the two that we used in carbonates, we add another ones that are also high in the reactivity series. We'll have those ones that are very stable, but they have water of crystallization. What happens when you heat is the water is only low. Yes. So otherwise the rest will form now an oxide, sulfur 4 oxide, and water. So I want you to see nitrates in a form nitrogen 4 oxide or nitrogen 1. Yani in a form an oxide of nitrogen. Sulfates, sulfur 4 oxide. Carbonates, carbon 4 oxide. So all these things will decompose to give actually the respective gas. With respect to, it gives the respective gas. I'm saying with respect to the compounds or the elements that it has. For example, carbonate has a carbon and oxygen. So it will automatically, it will give us an carbon 4 oxide. So those ones again. So the upper, those ones that are very high in the reactivity series are not affected. But as you go down now, the metal oxides will give sulfur 4 oxide and water and an oxide. So that one is the same, except ion 3, which that one is the, it gives two gases. It gives two gases for ion. Ion 2 gives two gases, sulfur 4 oxide and sulfur 6. So actually I've mentioned that most of the oxides are black. As you can see, ion, let us start with zinc. Zinc, of course, we have a special case with zinc, and then we have copper 2 sulfates, which has water. So you see the amount of water that is donated actually, or that is given out, is equal to the water of crystallization. Chlorides, we do not normally talk about this on most of the time, because most of the chlorides are very stable. So we do not talk about this on most of the time. But remember, I want you to remember, I don't know, is this physics or chemistry? Now there's a problem of teaching two subjects that have related content. I think this one was also in chemistry, where we are combining HCl and ammonia. Yeah, it is in chemistry. Yeah, diffusion. Where we said now, tunaweka something, a cotton that is soaked in, tunatafuta tube, let us say a tube, a clear tube. Na unaweka cotton that is soaked in HCl east side na cotton that is soaked on ammonia on this side. Alafu unawacha, it will form a white ring somewhere, or a white solid somewhere in between. And then we say which one is diffusing faster than the other. And then we now say this one is denser than this one. So it is actually in both subjects. But yeah, so it is there. So it will decompose to give us that. This one actually is the test for ammonia. I was almost forgetting. This one, ammonia, E. This one is one of the tests for ammonia, and it's also one of the tests for HCl gas. We normally use it to test. If it's 1.2 pt, we say now that is ammonium chloride with ammonia. If it forms a white PPT when you're testing ammonia with HCl, we say that one now is ammonia. That one is some of the ways to identify. If that one is okay, copper 2 chloride again, it will form copper 1. It only donates 1 and chlorine gas, but it must be balanced. So unless there is a query, is there a question? Have I moved too fast? So uses of salts, these are fertilizers. So fertilizers, I don't mention any. So we have ammonium sulfate. Let me just say sulfate, the dressers and the rest. Food additives, I think we had mentioned that one when we started. It can be used as a food additive. Also, when you talk about food now, we categorize also ammonium, sodium hydrogen carbonate. Inatumikanga kwa baking powder, ile inafanyia vitu ifure. So we normally use sodium carbonate is used. We'll talk about this one again in form 4, acid bases in for softening water. It is normally used to soften water, both soft and hard water. We'll talk about that one later on. Making of glass and detergents. I think this one is mentioned again in form 2. There's another topic in form 2 mentioned this one, which is in I think carbon and its or something. It is also carbon and its compounds. Yeah, carbon and its compounds. And then we have fireworks and powder. Yeah, potassium nitrate actually is very reactive. So it's normally used in that one. Calcium sulfate, plaster of Paris. It's normally called the plaster of Paris. Plaster, ile plaster yenye mtu akivunjika anawekewa hiyo kitu is normally calcium sulfate. It solidifies very quickly. It's normally a liquid, but when exposed to air or the atmosphere, it solidifies very quickly and becomes very hard. So that one. Calcium chloride is used in road surfacing because it becomes a liquid very quickly. The liquid mean it becomes a liquid very quickly. So kama ilikuwa imekuwa solid, ukimwagia hiyo, it can defrost. Is it called defrosting? Yeah, defrosting, kutoa ikuwe liquid very quickly because it will bring in water. Extraction of sodium metal. That one, we'll talk about that one in metals. We have a topic called metals. Actually, you will see this is normally used in extraction. It is not normally an electrolyte. In that case, it is normally used as impurity to reduce the melting points and the rest. And then we have calcium chloride is applied on roast to help melt. So that one is the same thing that I mentioned in number 6. It is the same thing. Defrosting, yeah, during the winter. Unless there is a query, a very serious one, I'm open to hearing any of your questions as I wait for the answers of the two. So I'll take you back. That is the end of SAS. Now, something form 2 is actually the what do you call it? Is actually the foundation. I can't say, let me just use the word foundation. It is a very easy topic, yet at the same time, a very confusing one. If you mess up kidogo while you are doing when you are giving, especially the procedures that are used in preparation of the sauce in the lab or anywhere, if you mess up a little bit and then you score very low. Again, writing of ionic equations, if you are writing an equation and by mistake you forget to balance the equation, that is number one. The first error is forgetting to balance the equation. That means the ions will not be balanced, so you cannot cancel one and leave out one. So balancing of equation, states of the equation. If you forget the state, that means you don't know what to cancel out. You don't know if it is actual or solid. And then when you are writing and you mix, you interjoin, you mix the capital and the small letters. That is number one. I want to combine the two of them. Mixing the capital, for example, E, this one is okay. If you wrote a P, which is small, and a B also, which is small, that one becomes wrong. It must look capital. Because you know the meaning of P, let me just write as an example. P, this one, a P that touches that. This one is a capital P. This one is a small p. So if you write something like that, it is wrong. If you touch this one, for example, I think this one is because of the cam scanner. When you touch, when you make, when the words are touching or the symbols are touching, the the elements, in that case, the compound, anything. When it is touching, for example, I've written this way. P, let me just P, P, and then I write here this way. This one again is wrong. So you should know. You should know how to write those ones. So you should know. I wish but I think there will be a class. I think I even offer a 1 hour lesson when we start for free. I'll just teach you on how to write chemical word equation. I think that one. I think maybe people know how to write word equation. Very few people normally don't know how to write it. But the chemical equation itself will do a lot of writing chemical equations. Of course, balancing, identifying how you know how this one came to be PbSO4 and not Pb2SO42, or how the other one became Mg and opening bracket NO3, you close the bracket 2. I think we can do that on another time. So unless there's a query, I'll share a few questions. I think I'll share a few questions. I'll share a few questions actually from the textbook, from two textbooks, which are anyway it's first scale B in terms of lessons, in terms of questioning and the rest. Questioning. It is normally very good because it's normally standardized. It's normally standard. So I'll just take a picture. Unless you have, if you have the book, I'll take a picture of the question and then I post it on the wall. Unless there's a query, I think we can come to the end of that lesson for today. Unless there's a query or somebody has to say something, I wish you a very commit night. So I will wish you a good night and all the best as you prepare for that exam. Just beat it. Bye.